This acid was given to me by a fellow refiner who's giving up on the process. The reason being he's losing too much gold when he's boiling up all of his hydrochloric acid and hydrogen peroxide. Now, literally, I've tried this. I've tried his solution, his recipe for what he's doing, and I was also melting gold into the solution, which means there's not only copper here, there's gold, the gold that he was losing, and also some traces of silver. I've done a stannous chloride test on it, and there is gold present in it, and that's why I'm going this way. On these motherboards, the BGA sockets, the ball grid array, are usually gold plated. You can't see it under the solder, but that's why I process it further and longer to dissolve all the lead and tin to get to the gold and then dislodge the gold. The boards I've scorched just to degrade the paint. See all the gold particles? This is why I filter out the mixture. What I'm seeing, high specification e-waste like this is loaded with gold and silver. They don't spare an expense on it. Now, some people are asking why I'm not cementing the gold out first. Well, that's the smallest amount in the material. I want to get the copper out first, and as I've said before, then I'm going to go for silver with silver nitrate, and then I'm going to go for the gold. But I'm going to take all the copper out before I start processing the other metals. I just want to reduce it and make it far more efficient. You can see the process is working because I'm plating out copper onto the stainless steel cathode. And yeah, it's a bit rough in stages, but that's because of the surface area. There's not enough surface area, so it's flying into the plate. Plating out excellent quality copper. You can see where it's sticking or adhering to the stainless steel plate. On the other side, it's quite rough, a bit like sandpaper.